In this video, we are going to see the classifications of transistors. So, first of all, the transistor, it is a device that converts and one form of energy into another form, so that the another form it can be, it is measurable, and it is can be easily transmittable, and it can be easily handled. So on the whole, we can say it is an electronic device which converts some physical energy or physical force into an electrical signal that can be easily handled and transmittable. Okay, so this is the definition of a transistor. So for example, we can say the transistors are like thermistors, thermometers we are using, and sensors we are using. So these are some of the examples of the transistors. Classifications of transistors are classified on different bases. One, on the basis of the principle used, the transducers are classified as capacitive transducers, inductive transducers, and resistive transducers. Another such one classification is active transducers or passive transducers, and primary or secondary transducers, analog or digital transducers, transducers or inverse transducers. These are some of the classifications of transducers. They are classified on the basis of the output we are getting and method of conversion of one form of energy into another form, and based on the applications we are using. So on this categories, the transducers are classified on these types. The active transducers are classified as photovoltaic transducers, and the thermoelectric transducers, piezoelectric transducers, chemical transducers, and various other types of transducers or active transducers. And another, it is based on the transduction principle you are using. So transduction principle, the capacitive transduction principle, inductive, piezoelectric, photoelectric, photovoltaic, photoconductic. So these are some of the transduction principles we are using. So analog and digital transducers. An analog transducer, it is which converts the input signal into an output signal, and which is an function of time, such as we are using thermistors, or strain gauge we are using, so or thermocouples we are using. So these are some of the analog transducers. So these output will be a continuous function of time. So digital transducers, it converts the input signal into an output signal in the form of the pulses. That is, it gives the output as a discrete signal in the forms of zeros and ones. It is a discrete output signal. These transducers, or nowadays it is more popular because it having lot of advantages, because we are more moving towards the digital world. So digital measuring instruments, it is very easy to build and maintain. So we are moving to digital transducers now. So due to this fact, the digital signals can be transmitted over a long distance without any distortions, or any amplitude variation, or any frequency variation. So it is more convenient, we are moving for digital transducers, since the output is a discrete signals of zeros and ones. Transducers and inverse transducers. Yeah, transducers, we know transducers, it converts one form of energy into another form of energy, and here inverse transducer is that it converts an electrical signal into one not measurable, non electrical signal. So supposing a piezoelectric crystal. That is, you know that a piezoelectric crystal. So this crystal will what to say, due to these surface variation in the crystal, some electric voltage will be produced in the piezoelectric crystal. So inverse can be produced. That is, when we apply some what to say, voltages, there is a misplacement or some dimensionality changes may occur in the piezoelectric crystal. So that is also measurable. It is one such type of inverse transducers. So so this particular inverse transducer, it is used in the feedback measuring systems. So wherever there is we have to need a feedback system, we can go for an inverse transducer. It is actually an it works on the principle that the input will be an electrical signal, the output will be an low power non electrical signal. So a transducer, non electric signal into an electrical quantity. Inverse transducer, an electrical input to the non-electrical input. So these are some of the factors to be considered while selecting a transducer. The first one, it is transducer must have low input impedance and high output impedance, so that we can go for loading effect, and it should be sensitive to the desired signals, and unwanted signal, it should be less insensitive, and it can able to work in the corrosive environments, and it should be protectable under overload protections. Okay, thank you.